unfortunately, or fortunately, depending on how you look at it, mobile is not a monolithic industry. So mobile is a very, very diverse landscape. So I'm gonna go over a very, very quick history of what the landscape looks like right now. There are two ways you can look at it. The easiest way is by looking at the software platform itself, or the operating system, the mobile OS. What may not be commonly known is that prior to 2007 and prior to iOS, there was already a very diverse landscape of smartphone operating systems. They're just not maybe not as popular as they are now, or maybe not targeting the same set of consumers. But prior to that, we already have a very good set, with a very good feature set for that era and for that technology. Now, of course, there was a very tumultuous event, 2007, which brought about what most people say a rethinking of what smartphones should be today. This group these group of technologies paved the path for higher expectations on smartphones, higher usability. Then you have the next wave. Then you have the latest wave now. So it is a very, very diverse field. Each of these operating systems has their own technology stack, way to develop, tool chains. So is the answer to develop for all of them? Not necessarily. Among this group, the only set which may have some market relevance, not necessarily, I'm not saying everything else is irrelevant, but this is what most people still have, or what the market still has presence for. And don't be deceived by the numbers. We may be tempted to say, since this is a cross-platform talk, that if Android has 75% of the market, why not just target Android? Everything else seems, or aside from iOS, seems a bit irrelevant. But it's not just a matter of market share. You have to also consider revenue generation. And up to now, iOS will pretty much trump revenue generation amongst all the other different platforms. So there may be much fewer users of iOS, but they tend to pay more. The others, these are the things to watch out for. They're open source, they're supported by some OEMs, there's still products coming out. And as if the industry has taught us anything, you never discount any particular technology. You never know what will happen next year. We talked about it from the software perspective, but you also have to consider the hardware. This is actually another key driver, or another key aspect where we're going to be challenged with cross-platform development. What most people consider cross-platform, they will consider smartphones and tablets. But there is a convergence going, and the thought that's coming in today is that there should be no difference between that and these. There is a drive towards convergence towards these devices, that your applications, that the experience between them should be seamless. But these aren't, again, your only devices to consider. What's the trend right now? Okay? Kiosks, smart TVs, handhelds, consoles, wearables. What's not included here are is automotive. Cross-platform is a deceptively simple term for a very significant challenge. Okay? And what we're trying to do is find ways so that to target as many of these as our market demands, and then make sure we have quality applications that offer a seamless experience across as many as we need.
These are the grievances people have with cross-platform development. They tend to say that the installers become very large. They use too much memory, performance is low, or you cannot access enough APIs. Now, here's why. So first and foremost, you pick a language. There are many tools like this: Java, JavaScript, Lua, Ruby, C#. As a programmer, you develop in that language. You then feed it to a tool. What the tool will do is it will add a virtual machine or runtime environment to your code. Bundle the virtual machine with your code, put it together, and call it a native app. So, to address different platforms, you supply different virtual machines per platform. So, to put a Lua app on Android, you must have a Lua virtual machine that works on Android. You bundle that with your Lua code, and there you have the tool. And then same for each language here. One issue that is demonstrated here in the picture is that these are not usually things that you can run in a browser because there are no runtime environments for those things that would work in a browser. Here's another approach. We have the C++ approach. Not really a cross-platform approach as such. It's an approach where, as long as there's C++, it works. So it's effectively a C++ library that you use on many platforms. The good thing there is that many platforms do support C++ in some form. However, with limitations. On Android and Windows Phone, you can do C++ now, but not as a really full-fledged citizen of the platform. On browsers, you cannot still run C++. And now we have on iOS, C++ still works. Swift, however, is not a C++ compatible platform anymore. So if that platform develops, this approach will also potentially have new issues. Those things that you hear on the web and on other places about cross-platform development, take it with a grain of salt. It is true for those kinds of approaches, but given the right architecture, because we are engineers, right? We are about correct architecture. If you architect the solution well, cross-platform development can be done, and it can be done with the performance of writing code for different languages.
When we automate testings, yes, it's like a keylogger, right? You log everything that it does. Whatever you do, you log everything. And when you execute the keylogger, everything that you did was executed the way it is. So that means gaining access to my program for my apps, or you log into a secure database like that. So how can we assure ourselves that this software that we're using to test it is not used to gain access to our, like that?
As a programmer and as a hacker, when you use these UI automation tools, you will feel like, wow, there's tremendous potential here for making viruses. Definitely, that is the feeling that you'll get. And I will not be surprised that some of that would happen on Android. Because in theory, you would be able to make a program that will install it on some other device and then it will start doing stuff. However, it is not a keylogger. The UI automation program, it only executes the things that you as the programmer did. It does not record anything. So that is not the security concern there.
Because both of your product promise that we will be able to deliver a natively developed product. So how are your two products different from each other?
It's basically the same C#, what you get from Microsoft, and the same API that you get from iOS and Android. So we built a runtime. So what I saw from Equila is, what Equila does is, it's much ahead in the process cycle. What they do is they convert it to the local language, and then they rely on the compiler to do that work for you, right? So what we do in case of an iOS and Xamarin is, we use the same LLVM compiler that Objective-C uses. The difference is that we compile to that LLVM compatible IL, if I can call it, and then we compile that. And his is like, it's directly on Objective-C, and the Objective-C compiles. That's the difference.
Over the past couple of years, when Apple moved from iOS 6 to 7, and now with Google moving from KitKat to Android L, there's a big emphasis on design. The human interface guidelines of Apple from 6 to 7 became very strict. Now with Android material, it's all flat. Yeah, it's all flat. They have their own look and feel that's very integrated to how you build a platform or how you build a program. How do you guys plan to address this? I mean, it was probably easier when it was with 4.0 and iOS 6 because you could get away with some UI elements that look alike. But as you move into these very different OSs, I'm thinking, and I don't know if it's a correct assumption, that cross-platform development might be a little bit harder because of design.
If you want your app to look exactly the same on all platforms, like really have your own look, you can do that. then again, if you wanted to adopt the common look of the platform, you can also do that. It's really up to how you want it. Personally, on the apps that we make, we tend to make the app look like itself, so it retains its own look regardless of platform. But of course, there are some who want it otherwise, and that's really their option as developers.
Yeah, maybe to also ask, like, since Accenture has a mobile development practice, to see how you approach it from the standpoint of UX design and also in the face of changing guidelines.
Personally, of course, I dislike, up to the point of detesting, applications that don't adhere to guidelines. I'm an Android guy. I like Android look and feel. I appreciate iOS, but I don't want Android apps to look like iOS. Consulting app. Which app store, if you're an enterprise, if you're a business, which app store or which application store is most likely going to reject your application if it looks like another application or another platform? iOS. Okay? Android may, if they catch you, if they actually take the time to look at your app. They,
Microsoft will.
yeah, Microsoft will.
But
Although right now sorry to say, but the market share of Microsoft is not big enough to be. Not yet.
Not yet.
Yeah, but you never discount Microsoft. So if that's the case, and you have limited resources to design, you have limited resources to develop, which UI guideline are you going to follow? So that's the consulting answer, because that is what most business owners and business clients and designers will tend to gravitate towards. 75% of my paying market uses iOS. Apple is most likely to reject my application if I don't follow their guidelines. So cost of development and maintenance factored in, I'll just make it look like iOS. And that happens all the time.